What is going on, guys? Welcome to your 30th chemistry tutorial, and in this tutorial I'm going to be talking to you guys about electronegativity. Sounds awesome? It is. Now, electronegativity is defined as the strength an atom has to attract a bonding pair of electrons to itself. What the heck did I just say? Basically, it's the force that an atom has to attract other electrons. Okay, that kind of makes sense. So let's go ahead and take a look at something like hydrogen. Now we already know that every atom attracts electrons, and we know this because the electron is always whizzing around the nucleus. It doesn't just go flying off into space. It actually is attracted to the atom. Now, the force of that attraction, we actually give it a name, and that is called the electronegativity of that atom. Now, we give it a name because depending on which atom you're talking about, the electronegativity has different values. For example, if you have a value of 0, it would mean that it would have no attraction whatsoever, and in that case, the electron would just go whizzing off into space somewhere. However, some atoms have an electronegativity of 4, like 4.0. Now, what this means is the attraction is really strong, and that atom has a very, very strong attractive force to that electron. So 0 is weak, 4 is a really strong one, and they all range from somewhere in between. Now, as a general rule, let me go ahead and this is probably going to be really ugly, but let me go ahead and draw a makeshift periodic table. Oh yeah, that's a good looking table right there. Wow, that's bad. But anyways, as a general rule, and I say this and I want to emphasize general because there are plenty of exceptions, but as a general rule, the electronegativity of elements increases from left to right. In other words, they are weak on the left-hand side and stronger as you get closer to the right-hand side, and also it decreases from top to bottom. In other words, the strongest elements are on the top right and the weakest ones are on the bottom left. So that is what electronegativity is. I can't talk today, and that's why it's important. So whenever we take a look at something like, let's say, our hydrogen bonds, we have a hydrogen that's bonded with another hydrogen. Well, I know I didn't go over the exact figures yet, but the electronegativity of hydrogen is 2.1. Now, that's the electronegativity of this hydrogen right here, and this one over here also has 2.1. So that pretty much means the force that these hydrogen atoms can pull on these electrons. Now, since these two different hydrogen atoms are pulling on these electrons with the same exact force, those electrons are going to share evenly between this and this hydrogen. And that's what we call, well, I won't go over the different types of bonds, but it's called a nonpolar covalent bond. It pretty much means that your electrons are shared equally between the two elements. However, if you have something like 2.1 and 4.0, then the electrons would be more attracted to this element over here, and that's what we're going to be covering in the next tutorial. Depending on the electronegativity of your atoms, the electrons can either be really attracted to one and not attracted to the other, or maybe not attracted to either of them, and we're going to be going over everything in the next tutorial. I just want to tell you guys this. Electronegativity is important not just to know how attracted the element is or the atom is to the electron, but it's also useful when determining the different kinds of bonds that can form whenever you combine two or more elements together. So that's what you have to look forward to. Thank you guys for watching, and I will see you guys in the next tutorial.